So now we are going to discuss about the rate monotonic scheduling. So in the last video we have discussed about the priority scheduling. So the same example we will discuss in the rate monotonic scheduling also. So the rate monotonic scheduling is used to schedule only the periodic task using the static scheduling with preemption. Okay, so consider that same example what we have used for the priority scheduling. So consider there are two tasks P1 and P2. The period is for P1 is 50, P2 is 100, and the execution time for P1 is 20, the P2 is 35. Okay, so the deadline is also same as the period. Okay, now the process which have the minimum period or execution time having the highest priority. So as per this, that the P1 having that minimum execution time, and so the P1 is having the higher priority. Now we see the scheduling. So this is the timeline. So divide that for each 10 milliseconds. So 10, 20, 30, 40, 50, 60. Okay. Now the P1 is the highest priority task. So the execution time of the P1 is 20. So the P1 completes its execution. Then P2. So at time 0, the task P1 and P2 arrives. Okay. Next we start the execution of P2. Okay. While the P2 is executing at 15 milliseconds, the another P1 will be coming for the second period. Okay, so the remaining execution time of the P2 is, so 5 millisecond is remaining. Now it start executing the P1 again. So the P1 will be executed for another 20 milliseconds. After completing that P1, now P2 will be executed for the next 5 milliseconds. Now here only again the P2 and P1 again comes. So while the P1 comes, the P2 having the higher priority, the P1 will be executed. Here P1 and P2 arrays, so and go so on. So while we have scheduled this same task in the priority scheduling, there was the deadline has been missed for P2. Here that problem has been solved. So the rate monotonic scheduling is only used to schedule a periodic task using the static scheduling with preemption. Now we see the another example in the rate monotonic scheduling. In rate monotonic scheduling also there is a deadline missing problem. I show you that with example. Consider there are two tasks P1, P2. The period for P1 is 50, the P2 is 80. That execution, this is the period. The execution time is 25 and 35. Okay, so we calculate that ratio, that is equal to 25 divided by 50 plus 35 divided by 80. So it is 94%. So there are even 6% is CPU is idle. But even though there will be deadline missing. See this. Okay. Consider this is the timeline. So divide that again by using the 10 milliseconds slot. So 10, 20, 30, 40, 50, 70, 80, and so on. So here the P1 is the higher priority as per that the minimum execution time and period for is P1 is having that so P1 is having the higher priority, right? So the P1 started its execution first. So at time 0 the both P1 and P2 arrives. As the P1 having the higher priority, it starts its execution and it completes at 25 millisecond. So this is P1. Now we are scheduling that P2. So the P2 will be so execution time is 35. So it will be executed for up to 50. It need to be executed for up to 60. But here in 50, the next P1 arrives. So the P2 has been preempted. So the P1 have started its execution. It will occupy that CPU for up to 75 millisecond. So which one? The P1. So after P1 completes the 10 millisecond of P2, the 10 millisecond of P2 is remaining. So it completes its execution, it starts its execution again and it completes. But at time 80 millisecond, the P2 has been arrived again. So before that, the previous P2 needs to complete. There is a 10 minutes millisecond delay here. So here the deadline has been missed for P2. So again there is a problem in rate monotonic scheduling. Even though we have preempted the task, we assign the different priority then compared to a priority scheduling. Again there is a problem in deadline missing. So in the how we are going to overcome this, before see that we see the one more concept, the worst case CPU utilization for scheduling n task. Worst case CPU utilization for scheduling n task, okay, is n into 2 power 1 by n minus 1. So this is the worst case CPU utilization for scheduling n process. Okay, next. So the deadline missing with rate monotonic, how we are overcoming this? See that next two thing. So earliest deadline first. So consider that same example, the P1 P2, the P1 period is 50, here it is 80, that is P. The execution time is 25 and 35. Okay, so here the highest priority will be given to the task which having the earliest deadline. Okay, consider this. Consider this timeline. So again, provide that 0, 10, 20, 30, 40. Okay, so time 0, two process has been arrived, that is P1 and P2. So the P1 having the earliest deadline. So the P1 has been assigned to the schedule, assigned first, and the execution time is 25. Okay, the P1 has completed its execution. Again, the P2 has been assigned. So the P2 execution time is 35, but while go here 50, there is another P1 comes. But the for this P1, the deadline is 100. Okay, here the deadline for P1 is 50, the deadline for P2 is 80. So the P2 what we are executing, which has been allocated to the P2 in the first period, its deadline is 80, then it is less than the deadline of P1 in the period 2. So the P1 has to complete its execution even though P1 comes in the next cycle. So it completed its execution at 60 millisecond. Now the P1 starts its execution. So it occupies the CPU for next 25 millisecond. Okay, even though at time 80 the P2 will be coming again, even though here the deadline for this P2 is 160. So this compared to 100 and 160, this 100 is less. The P1 keep on executing. Once P1 completes its execution, the P2 starts from 85. So again in 100, again another P1 comes. The deadline for that is 150. This is less than that. So once the P1 comes, the P2 which start its execution here, it needs to be preempted. So at time till 100, the P2 will be executing. Once the P1 comes, it compares the deadline. So that P1 deadline is less. So it starts its execution up to 125. So the P1 then P2 starts its execution. So already it have utilized the CPU for 15 milliseconds. So remaining 20 might be there. So it uses up to 4. Okay. So I repeat this again. So consider there are two tasks P1, P2. The period is 50 for P1, 80 for P2. The execution time is 20 for P1, 85 for P2. Okay, here the process which having the earliest deadline having the highest priority. Okay, now consider the at time 0, two tasks has been arrived, that is P1 and P2. The deadline for P1 is 50. The deadline for P2 is 80. So the P1 is having the less deadline than compared to P2. So the P1 starts its execution and completes its 25. The P2 starts its execution. While it's executing, P2 is getting executed. At time 50, the P1 has arrived again. So the deadline of the second time the P1 is 100, that is less than this 80. So the P2 has not been preempted. It continues its execution. After that 60 millisecond, after that the P1 started its execution at time while P1 is executing at time 80 millisecond, the P2 completes its execution and so on. So next, proportional share scheduling. It ensures all application can receive n shares. Okay, shares of n shares of time. So consider there are 100 shares in total. Okay, out of that A is assigned with 50 shares. Then B is assigned with 15 shares. C is assigned with 20 shares. So if so um, so out of 100 shares, 85 shares has been already assigned. If there is a new request process comes the D, it needs the 30 shares. The admission control will reject the uh, process D because there is no enough shares of time here. Okay, that is proportional share scheduling. Thank you.